Welcome back to Operating Systems, Unit 1, Part 2. Today we're going to talk about different types of computing environments and different components of an operating system and what a system call is. So first let's discuss the difference between a single processor system and a multiprocessor system. In a single processor system, that just means that you have one CPU or one processing unit. In a multiprocessor system, it means that you have multiple processors or you have one processor with multiple cores. And although there are some benefits to having a multiprocessor system, there are also some considerations about the role of the operating system in managing these multiprocessors. Because although with multiple processes you can get more work done, the synchronization and the delegation of the work needs to be managed. And so the operating system, once again, needs to use overhead, which means use the resources to manage these resources. So there are different ways that a multiprocessor system can be organized, and one way is by using a asymmetric multiprocessor system. And in this type of system, what happens is one of the processors is the master and the other processors are slaves. So if you have an asymmetric setup, you will have assistance with your management with the processing units. If you have a symmetric setup, that means that all processors are treated as peers and all the management is done by the operating system. And one more thing about systems, multiprocessor systems, in addition to having multiprocessor systems, there are clustered systems. Clustered systems are those systems that are separate computer systems. They have their own clock and their own resources, but they work together in some type of network as if they were one system. So again, there are different considerations on how the management is done in a single processor system, a multiprocessor system, a symmetric multiprocessor, or an asymmetric multiprocessor, or a clustered system. And then the last topic I want to bring up is the concept of multiprocessing versus multiprogramming. Multiprogramming is just a system that allows multiple processes to be active on the system at the same time. So you can do multiprogramming on a single processor system. You just need to switch between the processes and only do one thing at a time. You can also do multiprogramming on a multiprocessing system, which just means you're using multiple processors to run multiple processes. And we will be discussing this term later in this course, this term degree of multiprogramming, and there are units that are part of the operating system that control the degree of multiprogramming. And what that means, it controls how many active processes your system will allow at one time. So let's just talk a little bit about some of the goals for multiprogramming. In multiprogramming, you have a bunch of processes, and processes are going to use the devices and use the CPU and use all of the resources. So what you want to have is a good mix of processes that are more CPU intensive and less CPU intensive, so that you can keep all of your devices and your processor busy and get the tasks done in a good amount of time. And then we have time sharing and multitasking systems. And in this case, you need to have your operating system help manage all of these tasks on the system. And because we will have multiple active programs, you will have a CPU scheduler, and the CPU scheduler, which we will be doing a lot of exercises on that later in the course. But the CPU scheduler will take all of those active programs, which are processes, and are ready to get on the CPU and decide the order in which they get onto the CPU. And another part of the component of the operating system that can control the degree of multiprogramming is if sometimes you only have a limited amount of resources. So once you have exhausted all of your memory in your system and you can no longer introduce any more tasks into the system, your operating system may have a unit that will swap, and it will swap either entire processes out of memory or parts of processes out of memory in order to give space for new processes to be introduced into the system. And we will talk about that when we get to schedulers and scheduling. So the components of an operating system is a complex software. So in order to analyze it, we just talk about the different managers that are part of the system. We have a process manager, a memory manager, a storage manager that creates a uniform look to the system and manages all of the files and information, and the kernel I/O subsystem, which manages the devices. Networking, protection and security, and there's a definition here between protection and security. Protection is controlling access of the processes by the operating system, and security is defense against attacks. And all systems will have part of the operating system, a way to interact with the system through a user interface. System calls are used by processes to request an action by the operating system. So what that means is there are privileged actions that are done on your system, like accessing files, allocating memory, communication between processes, and all of these tasks are done through system calls where the operating system will take over the system and not allow user processes to do anything that is privileged. And one of the ways in which this is implemented is through dual mode operation, where you have two modes of operation in your system. You have user mode, which the applications run in, and then you have kernel mode or supervisor mode or monitor or kernel. These are all, or privileged, these are all interchangeable. You only have two modes, user mode and the privileged mode, which is the kernel mode, and all privileged instructions must go through the operating system and give control to the operating system to do any of these types of operations. And the different types of system calls include those that for managing processes, for managing files, for managing devices, for updating information, and for managing communications. And the last topic I want to go over in this section is different types of computing environments. So when you're dealing with operating systems and this manager of your computer system, it not only depends on whether you have what the components of the software are and how you have set up your system calls and how all of that, but it also depends on what type of system you're actually using. If you're using a traditional computer system where you're just using your own computer and you are doing word processing and doing independent work on your system, and that's very different than a computer system that is getting connected to the network and is having to deal with, security issues because you're on a network and you are downloading stuff and all of that. So your operating system has a very different role in a traditional environment versus a distributed environment, and it's going to have an even different role in a mobile environment, because you have a different set of resources, a different way to organize the resources, and so all of these things need to be taken into consideration. You need to consider what type of environment you're working in, how your components work together, and if you have only one processor or multi-processors, how those processors are set up. So all of these things are taken into consideration, and in our next unit, we will be discussing design of operating system. This unit is just about concepts and definitions. So I encourage you to take the time to read the last few slides that are in this presentation about different ways that systems run multiprocessors and cloud computing and the Chrome browser, how it does multiprocessing, and take a look at this and start thinking about your case study and what you're going to be working on with that, which operating system you're going to choose. And I will check in with you again next week. Please email me if you have any questions, and thank you very much.